All right, think back to school for a second. You remember that one math rule that just made no sense? The one that felt totally random? Well, today we're going to pull back the curtain on it. Because it turns out there's a really simple, almost elegant logic hiding right there in plain sight. You know the one I'm talking about. Why is a negative times a negative a positive? I mean, it's the classic question, right? It's stumped students for, well, forever. It just feels counterintuitive, almost like a trick. But what if I told you the answer is actually part of this perfectly logical system? Let's get into it.
So to really get why these rules work the way they do, you don't need some crazy university textbook or a super complex proof. Nope, we just need to look at how these ideas are introduced right at the very beginning.
And get this, our guide for this entire deep dive is a single lesson plan for 6th grade math. That's right, it turns out everything we need to make sense of this is laid out right there in the simplest way you can imagine.
Okay, so first things first. We've got to lay down the basic grammar of how all this works. You can think of it like the code that runs the whole program. Once you get this part down, everything else just starts to click into place.
So here it is, the whole system, all laid out in one simple table. And yeah, the lesson plan basically says, memorize this. And honestly, for good reason, because look at the pattern here. For both multiplication and division, if the signs are the same, positive and positive, or negative and negative, the result is always positive. And if the signs are different, it's always negative. That's the key right there, consistency. This isn't just a random list of rules to trick you, it's the very foundation that makes the whole system work.
Okay, so we've got the rules. But, rules can feel a little abstract, so let's make this real. We're going to walk through the exact examples from that 6th grade lesson plan.
All right, first up, we're adding 2 negative fractions. Now to do that, you need a common denominator, right? So we change -1/4 into -2/8. Simple enough. Now we can just add them together. Think of it on a number line. You're already at -2, and you're going 3 more into the negative. That lands you right on -5. So the final answer is -5/8. Next, we've got subtraction. So how do you take a fraction away from a whole number like 2? Well, the trick is just to get them speaking the same language. We can rewrite the number 2 as the fraction 10/5, or 10/5. And once you do that, it's just a simple subtraction. 10 minus 3 is 7. Our answer, 7/5.
Multiplication is even more straightforward, really. We've got a positive fraction and a positive whole number, so right away we know the answer is going to be positive. All you do is multiply the top number, the numerator, 5, by the whole number, 3. That gives you 15. The bottom number, the denominator, just hangs out, so we're left with 15/6, which simplifies down to 2.5. Okay, and this one is a perfect example of how those rules all click together. We're dividing a negative number by a positive one. So step 1, what's the sign rule? A negative and a positive make a negative, so we already know our answer has to be negative. Step 2 is just doing the math. And here's a little trick. Dividing by 2 is the exact same thing as multiplying by its reciprocal, which is 1/2. So -4/5 times 1/2 is -4/10. Simplify that, and you get -2/5. See? The system it works.
Now, since I just threw that word reciprocal out there, let's just make sure we're on the same page. A reciprocal is just the number you multiply something by to get a result of 1. So the reciprocal of 8 is just 1/8. For a fraction, it's even easier. You just flip it upside down. So 2/3 becomes 3/2. This is a pretty key idea in the lesson plan, and, spoiler alert, we're going to need it for the final challenge.
Okay, so here's something interesting. As we're digging through this source material, this 6th grade lesson plan, we come across something that, well, it isn't about numbers at all. It's something else included as part of the day's lesson that seems designed to offer a totally different kind of motivation. And here it is, pulled directly from the source. It's a Bible verse, listed under the heading, Bible Verse for Day 2. So its inclusion here seems to be an inspirational element, something presented right alongside all the logical rules and math examples in this particular curriculum.
So, we've walked through the rules, we've gone through the examples, and our source material gives us one last thing, the homework. Let's just treat it like a quick little pop quiz, a way to see if this whole system has really clicked for you.
All right, you ready? Here are 5 quick problems pulled straight from the homework assignment. You can pause and work them out if you want. First, what's 5 plus -3? Second, what do you get if you subtract -2 from -5? Third, multiply -3/4 by 2. Fourth, divide 10 by -2. And the last one, what is the reciprocal of -8? Got your answers? Let's see how you did.
And boom, here are the answers. So, how'd you do? Did you notice that subtracting a -2 is actually the same as adding 2? So -5 plus 2 gives you -3. And for that last one, the reciprocal of -8 is -1/8, because remember, a negative times a negative gets you that +1. See? The rules always work.
So what's the big takeaway from all this? It's that math's rules, the ones that seem so random, really aren't. They're all part of this beautiful, consistent system. A negative times a negative is positive, not because someone wanted to confuse sixth graders, but because it has to be. The whole logical structure depends on it. And once you finally see that structure, the mystery just kind of vanishes.
And that brings us to a really interesting final thought. We spent all this time seeing how these strange-seeming math rules are actually part of a perfectly consistent logical system. But we also saw that this lesson plan included something else entirely, a moment of pure inspiration. So if math is this language of pure logic, where does inspiration fit in? What role does it play? It's a fascinating question to think about.